simple experimental design. Throughout this class, you will be looking at graphs, you'll be creating and designing experiments, and you'll need to know the basics in order to do so. So when we are first looking at experimental design, some of the things that we need to look at are the control. And with the control, there are control groups and there are controlled variables. Controlled variables are those variables that you keep the same throughout the entire process between each group and that sort of thing. The control group is the group that is used as a baseline, or the group that is used as a measure against the test group. So basically looking at the test group versus the control, basically the one that hasn't had that change, and is there a change between the test group and the control group. With control groups, there could be a positive control. A positive control is one where we know the outcome of what that control is. So it could be something that has been tested over time, and we know the outcome, and we're testing the new thing against that old thing. So if let's say you're looking for a new headache drug, and you're testing it against Tylenol, because we know how Tylenol works. We've been using it for years, and now we have this new headache medicine, and we want to test it against Tylenol to see how much better it is than the Tylenol is. So that Tylenol would be the positive control because we know the outcome of that. Then we can have a negative control. Negative control is a control that is not getting the change. It's not getting whatever that tested group is getting. So whatever it is that we're testing, the negative control isn't getting it. It's kind of the normal baseline. Then we need to look at our independent variable. The independent variable is the variable that is being changed. So whatever it is that is being changed from the control is going to be our independent variable. And our dependent variable is the variable that is being measured. So if you're in the lab, if you're in the field, whatever, basically you're writing down those numbers, those qualitative or quantitative data that you're taking is a dependent variable. When looking at a graph or forming a graph on a general whole, our dependent variable is going to be on our y-axis, and our independent variable is going to be on our x. So when you're creating your graph, you know what to put, you know where to put what. Or if you're looking at a graph, you can determine what is the thing that it was being measured and what is the thing that we were testing. So this is something that you need to make sure that you have down and that you can recreate a graph. Alrighty. So when we're looking at experimental design and we're thinking about basically our question, we need to come up with our null hypothesis, and we abbreviate that as HO. The null hypothesis is basically the hypothesis saying that our experimental data and our control data are essentially the same. So there's no difference between the controlled and the tested outcome. So if our test group is essentially the same as our control group, then we do not reject our null hypothesis. If they are different, if there is a difference between the experimental group and the control group, then we reject our null hypothesis. Okay, so our null hypothesis is that essentially our data is the same. If our data is different, then we are going to reject our null. If it's the same, then we do not reject. On the other hand, we also have our alternative hypothesis, and this is abbreviated HA. So essentially, the alternative hypothesis is that there is a difference between our tested and our control. So it's kind of the opposite of our null. So if there is a difference between our test group and our control group, then we do not reject our alternative hypothesis. You're probably going to run into null hypothesis more than the alternative hypothesis, but I wanted to bring this up as it is a part of the statistics. A couple other things that we need to keep in mind as we are designing an experiment are sample size. We don't want to just grow one plant. We don't want to just study one person. We want to make sure we have a large sample size. The larger the more accurate that we can be. Another thing is multiple trials. So how many trials has been done with this experiment? It could be multiple trials by the same person. It could be multiple trials between different entities. Basically, how many times has this been repeated? And are you getting the similar results each time that it gets redone? So essentially, we want to make sure that we have had a large sample size. The larger the sample size, the more accurate our data is. And then also having multiple trials. Is it repeatable? Can we get the same result over and over again? Alrighty, so that in a nutshell is experimental design. Alrighty, thank you.